7.3 is going to be about graphs. Some of this should be familiar. You should remember from Algebra 1 when you learned how to graph lines. And there are two main techniques to remember for graphing lines. The one that I prefer is something called the intercept method. And the intercept method is basically something most people would develop on their own once they realize how easy it is to plug in 0 compared to plugging in anything else. And you end up doing it twice. You plug in 0 once for x, and then you plug in 0 once for y. So if you plug in 0 for x, what that basically means is this part of the equation here vanishes. 6 times 0 is 0. And you're left with this super easy equation, 5y equals 30. Most people just solve that in their head and they get y equals 6. Reverse it, plug in 0 for y, and this part drops out. 5 times 0 is 0. The equation 6x equals 30. Most people solve that in their head. 30 divided by 6, they get 5. And if you're graphing lines, all you need are 2 points. If you know it goes through the point 0, 6, and you know it goes through the point 5, 0, all you have to do is get a ruler and connect those two lines. Or connect those 2 points with a line, like that. There are some situations in which the intercept method is not the best method. Typically, those situations look like this, where you have an equation that's been solved for y, and that's going to be a pretty common thing. Since we've been talking about functions here in Chapter 7, you'll notice that functions are almost always written y equals everything else. Or even more generally, they might say f of x equals everything else. So because of that, there's a pretty decent chance that your equation might look like this. This should be reminiscent of the mx plus b way of writing a line. And if you're writing things in the mx plus b style, you've got the y-intercept and the slope, and that leads to a different graphing technique. In this graphing technique, you start by plotting the y-intercept on the y-axis at whatever value it's supposed to be. In this case, it's supposed to be -2. And then you use the slope of -5 over 3 to rise and run an appropriate amount. Now, when you're talking about a negative slope, one thing that students often forget is that the negative can be the rise, or the negative can be the run, depending on what you want to do. Like in this case, if I rise -5, 1, 2, 3, 4, 5 down, and then I run 3, I end up over there. Or on the other hand, if I rise 5, 1, 2, 3, 4, 5 up, and then I run -3, I end up over there, it doesn't really make a difference. They're both the same line. When you take a ruler and lay it through any two of these points, it ends up going through the third one as well. So don't forget how to graph lines. That's from Algebra 1. We're going to assume that you've already mastered that. The things you're going to be asked to graph here come in two different categories. One category is other types of graph, quadratic functions being one that you may have seen before but perhaps not graphed, and other things too. And regardless of whether it's a quadratic function or a cubic function or a logarithm or an absolute value function or something even stranger than that, I'm going to have you start with one basic technique for all of those. In all of those situations, use a table of values. It's not super sophisticated, but it's guaranteed to work as long as you put in the time and the effort of actually plugging numbers in. Thing is, unfortunately, some students are lazy and they just don't want to take the time to plug numbers in. Well, I'm sorry, you're not going to be able to get the graphs if you're not willing to put a little bit of time in. So here, you would plug numbers in, and because of what we were just learning a second ago, you probably like the number 0. If you plug in 0 here, you get -3 very quickly and easily, and that's 1 point. And then you could try plugging in something almost as easy as 0. You could plug in 1. 1 squared is 1 plus 2 is 3. 3 minus 3. You get 0 for that. But remember, this is not a line. 2 points is not going to be enough. 2 points, you don't just grab your ruler and connect the dots and you're finished. The bad news is you got to keep going. You got to plug in 2 and 3 and 4 and try plugging in -1 and -2 and -3 and keep plugging numbers in until you have enough points to see what the thing looks like. If you plug in 2, you get 5. You plug in 3, you get 12. Plug in 4, let's see, 16 and 8 is 24. You get 21. Going in the other direction, if you plug in -1, you get -4. I should probably be plotting these, I just realized. 1, 2, 3, 4, 5, there we go. 312 is up off the top of the thing. 421 is way off the top of the screen. Going in the other direction, if you plug in -2, you get -3 again. Notice this is definitely not a straight line. This is doing something else. If you plug in -3, you get 0. And so on. And once you plug in and plot multiple points like this, notice we did 1, 2, 3, 4, 5, 6, 7, 8, well, only 7 because one of them didn't fit. We plotted 7 points in here. And at this point, we're starting to see what the thing looks like. This graph is a curve of some kind. If you're curious about what it's called, this type of curve is called a parabola. I won't test you yet on the names or anything, but plugging in points is the easiest, most direct way to figure out what the thing looks like. The other situation where graphing is going to happen, it's going to happen in a little bit more of a subtle fashion, a little bit more of a background sort of a fashion, and that is word problems. The idea here in this word problem is a fairly straightforward one, and it's obviously made up and just for fun. You're shoveling diamonds into the back of a pickup truck. It can carry 1,000 pounds of weight. After 3 minutes of shoveling, you've got 190 pounds there. A minute later, it's up to 300 pounds because your friend is a really fast shoveler, it looks like. And then what we're trying to do is predict when it's going to hit 1,000 pounds so that we can drive away. This is a situation where we need an equation so that we can solve the equation and find something from it. So I'm not going to solve the whole word problem here. I'm just going to go through the steps of finding the equation. And here's the reason why this is function related, why this is related to graphs, how this is similar to the things we were just doing. 3 minutes of shoveling and 190 pounds of diamonds, you can think of that as coordinates. There's two values that are related. You could say x and y. X is 3, y is 190. And then when we've got 1 minute later, there are 300 pounds. That's a second point. And you should know pretty well what you should do with 2 points. If you have 2 points, you find the equation of the line. Do you remember how to do that? Might want to pause the video, see if you can get the equation of the line out of that, and then press play and see if you get the same equation I get. Okay, so to get the equation of a line, first step is figure out what the slope is. So y2 minus y1 over x2 minus x1, rise over run. So that's going to be 110 over 1, so the slope is 110. And then the next step is to plug into the point slope equation. y1 is 190. The slope we just got was 110. x1 is 3. So distribute in the 110, and you've got 110x minus 330. Add the 190 to the other side. So let's see, 330 minus, you get negative 140. Is that the equation you got? Same equation I'm getting. And then if you wanted to completely finish answering the question, that's the equation you would use to do it.